Hello guys, how are you doing? You doing great? I hope so. Today we're gonna speak about something really important, which is called oscillatory motion. But before we go into oscillatory motion, we gotta go back into time. In your first year in secondary school, you studied some topics. One of them called translational motion. So what is translational motion and what is the relation between our topic today and translational motion? Okay, translational motion is defined as a motion between two specific points. Look at this example. This is the start point of motion, and this is the end point of motion. If I go from here to there in a straight line, this is called translational motion. So it is defined by two specific points. Or even if I go like in a curved path, it is called translational motion too. So the reason why we call it this, because we know we have a starting point and ending point. Okay? So what is periodic motion? We already know what is translational motion. If you really wanted to understand periodic motion, we will define oscillatory motion, an example of it. So you will understand the meaning of periodic motion. Oscillatory motion, this is the definition of it. What is it? It is the motion of a vibrating body about its rest position. What is rest position? We will know soon. Get down, boy, get down, girl. The rest position is that gets repeated through equal intervals of time. Okay, look at this simple pendulum in my left hand. I will push it right there, like this, and you will see this type of motion. What is that? Is that magic? No, man. It is oscillatory motion. This is called, is a middle position called what? Rest position or equilibrium position. So the pop, this is called pop or vibrating body or even anything. Okay. Repeat its motion between the middle position. So anybody like this, vibrate like this, called oscillator in our English language. Okay, look at this simple pendulum. I show you an vibrating example, and this is in the board. Okay, we will go in some concepts about oscillatory motion. Okay, first of all, if we like push it like this, the motion will stop after a period of time. Why? Because we have air resistance. So if we ignore air resistance, the motion will repeat itself until the end, will not stop if we ignore air resistance. But here in our problems and our course, we will always ignore air resistance. So the motion will be like this. The oscillatory motion will be like this. Okay. Go back and forth between its rest position. We have some concepts that we'll redefine in oscillatory motion. One of them called displacement. Look at this. This is called X point. Look at the symbol D, maybe like this. But any amount of distance, like from left to right, whatever, this is called displacement. Displacement is the distance between any point, like from left and right, the equilibrium position. Take care of it. If the maximum distance is 5 meters maybe, so the displacement will be less than this number, because distance and the displacement may be 1, 2, 3, 4, but not the maximum. And the displacement is a vector quantity, so it will be like the 3 meter or -3. How I can know this? In the problem, you will find a vector, like a negative or positive vector. So in this, if the vibrating body go right, so the displacement will be positive. The other side will be negative, like this, and the displacement, the unit of it, meter. That is the displacement. What is amplitude? Amplitude is the maximum what? Distance from the rest point position, equilibrium position, and the maximum point, even right or left, in the simple pendulum. This. Okay. Amplitude is the maximum distance from what? Here to there, here to there. This does not have to a vector. Why? Think of it. If we ignore air resistance, this what distance will be 5 meters, and this too will be 5 meters. So they will be equal. So I don't have to say -5 or +5, because we all know that this is only 5. It doesn't have vector, doesn't have positive or negative. So amplitude is scalar 1. Displacement, vector 1. Okay, we will talk about complete oscillation, we will talk about periodic time and frequency, and we will solve some problems. I will pause the video and continue. The third concept of oscillatory motion is called complete oscillation. How I know that the vibrating body complete one oscillation? Look at this simple pendulum. If this body start from X point and go like in the left direction, it will complete amplitude numero 1, and back to the 2 and 3 and 4. This is a complete oscillation. How I know this? Look at the direction of the body in the beginning, in the left, right? Okay, 1, 2, 3, 4. When it go back to the starting point, the direction of it is the same direction of beginning. So it is the motion of an oscillating body, like this pop, during a period of time when it passes through a certain point in its path of motion, 2 successive times in the same direction. This is what we call it complete oscillation. 2 successive time. That is it. Simple. This is a definition. We have another definition attached to term of phase. We will go in the 4 and 5 concepts of oscillation, oscillatory motion, and we will go in the phase stuff later. 4. T is a periodic time. It's simple. The periodic time T equal T over N. What is T and what is T? T is called the periodic time, and this is the amount of time of oscillations, and this is the number of oscillation. It's easy. If you want to have one time of one oscillation, it's called the periodic time. Okay. If I have one oscillation, what is the time of it? That is it. This is measured by seconds. This is have no unit, so the periodic time measured by seconds. Okay, the frequency is the reverse of it as a mathematical form. Mu equal N over T. And what is it? It is the numbers of oscillations in specific time. So we can see that mu, this is pronounced as nu is equal 1 over T, T equal 1 over nu, and this is measured by hertz, and this is measured by seconds. Okay, that is the basic concepts of oscillatory motion. We will solve one problem and end the video of it. I will pause the video and continue the problem. Example number 1. In the opposite figure, which is this, if the time taken by the pendulum to move from X to Z, this is two amplitudes, which is called half of a what? A complete motion oscillatory, or a half of oscillation. Half. From X to Z is 0.8 seconds. Okay, in my mind I will write this. What is it? It's half of a periodic time, T over 2. Okay, calculate 1. The periodic time, but this is answer. I wrote 2 T over 2 equal 0.8. So I will do like the scissors. It will be like this. T 2 times 0.8 will be 1.6 seconds. Okay. Because it's have oscillation from X to Z, two amplitudes. Okay. The periodic time, the periodic time, I will leave it like this. The frequency. The frequency, it is the reverse mathematical form of what? Of T, which is called 1 over T. 1 over 1.6 will be 0.625 hertz. Okay, that is P, the frequency. The number of complete oscillations through 16 seconds. Okay. In any oscillatory problem, the periodic time, the frequency will be a static number. You will use it to find another anything like this. So C, what is it? The number of complete oscillation. It needs the number. So number from this formula, T over T. Okay, so N equal T small over T capital, lowercase, uppercase. This is what? 16, and this is 1.6. It will be anything, like 10 oscillation. Okay. The last one, B, the time required to make 15 oscillations. I will use this or that, whatever, because T uppercase, nu, will be a static number. We will use it in any what you want. Okay. I will use what? I will use, he needs time. Time by this low will be the uppercase dot or time to n. This is 1.6 time 15, and this will be 16.5 whatever seconds. So this is an introduction, a simple introduction to oscillatory motion, and we will continue in another video. Thank you for watching. Leave a comment, subscribe, and hit the like button. Goodbye.